Hello, this is Dave Trower. I'm going to talk to you today about my advanced DragonBoard project. What I did is I did a thermostat proof of concept. Now for my thermostat, what I was thinking is I have a DragonBoard 410C with the sensor mezzanine board on top, and the sensor mezzanine board has the ability to flip a relay. And a relay is an electromagnet that flips a switch. And this allows the mezzanine board to use software to flip the relay. So my idea was, what if we had the air conditioner hooked to the relay, then we could use software to turn the air conditioner on and off. One of the features I wanted for this project is I want the DragonBoard to be running without a keyboard or a monitor. What I'm thinking is DragonBoard should be in the closet where the air conditioner is. However, in order to run the thermostat without a keyboard or a monitor, that means we need another way to set the temperature. So what I thought would work out is to use the laptop inside the house in order to set the desired temperature and send that to the DragonBoard. And also I thought it'd be nice to have a way to control the temperature from the outside world using the internet. So for this project I used both the AWS Greengrass, and I also used a Greengrass API. I have AWS Greengrass Core running on the DragonBoard 410C. I have a laptop running AWS Greengrass SDK, and I have an EC2 instance on AWS running the Greengrass SDK. So here's kind of an overview drawing where you can see the DragonBoard, the laptop, and the EC2, they all communicate together using the AWS Greengrass Core. And I have two IoT objects. I have one called temperature and one called desired temperature. And to kind of get everything started, what we have is a temperature sensor, and it's hooked to A0 on the sensor mezzanine board. And this will send the temperature to the sensor mezzanine board. And the way this all works is there's an Arduino sketch, and there's a makefile that uploads the Arduino sketch to the sensor mezzanine board. The sensor mezzanine board then talks to the temperature sensor. The Arduino sketch then sends the temperature sensor to the serial port, and this is how the DragonBoard and the sensor mezzanine board communicate. I have a Python program that reads from the serial port and it writes the temperature to the temperature.txt file. Now let's take a look at how that all works. Okay, now I will SSH to the DragonBoard. Now we'll change to the proper directory. And I have some script files here. And I will run the script that will run the makefile and send it to the sensor mezzanine board. And now, if we do a tail minus F on the temperature, temperature.txt file, you can see that it's being updated roughly every 20 seconds. Okay, so the next part is we have a Java program that reads that temperature.txt file, and it publishes it, the value it reads, it publishes it to the temperature IoT device. So let's take a look at that. So on the DragonBoard, I have a script called start java.sh, and we'll go ahead and run that. And what this does is it'll read the temperature from that temperature.txt file. And as that file is updated, it'll keep reading it, and it will send the updated value to Greengrass. So let's take a look at the AWS console. I will go to IoT and then to Greengrass. Once there, I will go to my devices. I will go to a device called temperature, and then I will go to shadow, and you will see it is now 69.8 degrees, and it is currently 2:03, so that is the time. So you can see right now the current temperature has been sent to AWS Greengrass, and it's now this first device, IoT device, knows the temperature. Okay, so the next step is to update the desired temperature. What I've done is I've written a Java program that runs on the laptop. It's a Spring Boot Java program, which means it has a web server built in. This allows this Java program to serve up a web page. The web page is just an easy way for me to have a graphical user interface. I just point my browser to localhost 8080, and that hooks the browser up to itself, and it will see the web page. When I hit submit, it will publish the desired temperature, and it will go to the desired temperature IoT device. So let's take a look. Here I'm going to set the desired temperature to 80 and go ahead and hit submit. And it says desired temperature has been changed. Let's go to IoT, or let's go to AWS console, go back to Greengrass and devices, go to desired temperature, go to shadow, and sure enough it's set to 80 degrees, and you can see it's at 211, so it's taken the desired temperature from the web page and sent it here. So now we go to the next part of this. There is a Java program running on the DragonBoard 410C that will look at both the temperature IoT and the desired temperature IoT. And if this was a completed program, it would decide what to do and then flip the relay. So let's take a look at the program. Okay, we're back on the DragonBoard. I'm going to run the program called thermostat.sh. And what this will do is it will connect to the Greengrass. And after it connects, you can see here desired temperature is 80, the current temperature is 69, the air conditioner is currently off. And now it's going to sleep for a few seconds, and it's just going to be in an endless loop where it constantly gets the temperature, gets the desired temperature, and then decides what to do as far as turning the air conditioner on or off. And finally, we have one last piece to this project. We have an EC2 instance that is running that same Java Spring Boot program. And the EC2 has a really obscure name, so I went ahead and made a DNS entry for gladshire.com. So now anywhere on the internet, you could go to gladshire.com port 8080 and you can change the desired temperature. So let's take a look. You can see here we're at gladshire.com. I'm going to change the desired temperature to 65. Hit submit. Desired temperature is now 60. Finally, I have some advice for this. If you want to do a project like this, I really recommend you do the AWS Getting Started with Greengrass tutorial. I did the tutorial. There's about 5 parts. Each part will take about a half hour. I learned a lot doing the tutorial, and I really think that this made this project possible. So that's some advice that I have. When you create these Internet of Things devices in the console, you will get these certificate files, and the certificate files will have these really obscure names. They're basically based on numbers, like it'll be 157.private.cem. I really recommend that you rename, instead of having these numbers, that you rename it to something meaningful. For example, in this one, I have the files are either temperature dot something or desired temperature dot something, and that made it a lot easier for me to keep track with all these different files are. And finally, on the code that you write, use the get for source code control, because I made a couple mistakes and sometimes I had to back out changes, so that really came in helpful.